going to talk about degrees, radians, and reference angles. Okay, so when we're talking about doing this, you guys should be able to take an angle from the degrees to make the units radians, and from radians to make the units degrees. You should also be able to find the reference angle. Some things to remember. Well, first, you should be able to remember that 180 degrees is the same as pi radians. Okay, 180 degrees is the same as pi radians. You should also remember that every angle that we're talking about is going to start at the positive x-axis, but some of them are going to go counterclockwise, and these are positive angles to get to their terminal side, and some of them are going to go clockwise to get to their terminal side, and those are negative angles. Okay, so if you go clockwise, it's negative. If you go counterclockwise, it is positive. Okay, so I think that you guys have done some of this converting in science before, but that's how I'm going to set it up. So here we're trying to convert 2 radians. So we start with 45 degrees, and we want to have radians. So that means that we're going to put degrees on the bottom and radians on the top. And we want that value to be 1. So they have to be equivalent. So 180 degrees is equivalent to pi radians. And so we're going to be multiplying it by that. Let's move this over a little bit. I kind of got squishy town on that one. Okay. So now what we're going to do is we're going to simplify. So we can divide this by 45 and get a 1. Divide this by 45 and get a 4. And so now we're going to have pi over 4 radians. Oh yeah, I've already written that. Let's erase it. Okay, let's do it again. Here's another one. So we're going to start at 120 degrees. We're going to use our pi radians over 180 degrees so that we can get radians. Okay, so, well, first of all, they both have 10 in it, so we can divide by 10. And then they both have 6, so we can divide this by 6 and get a 2. Divide this by 6 and get a 3. So we're going to have 3. Nope, lied. So we're going to have 2 pi on the top and a 3 on the bottom. And so that's radians. And sometimes we see it written like this, 2/3 pi. It's the same thing. Okay, now what we're going to do is we're going to convert pi over 3 to degrees. So now we're going the other way. So now we're going to end up with degrees. So we're going to start with pi over 3, and this is radians. And then we're going to end up with degrees. So our radians are now going to go on the bottom. And so we're still using that 180 degrees is the same value as pi, okay? And so when we do that, we are going to be able to just have degrees now. Our pi's are going to simplify out, and divide by 3, we get 1. Divide by 3, we get 60. So this is 60 degrees. When we finish this unit circle, you'll never have to do this again for these because these are actually on the unit circle, so we are going to remember them. So here we have radians again, and we are going to get rid of the radians because we would like it to be in degrees. So we'll still use our pi is related to 180. And then the radians will go away. The pi will simplify to 1. And we divide this by 4, we get 1. We divide this by 4, we're going to get 45. So we're going to have 3 times 45, which is 135 degrees. Okay, So hopefully you see what we are using. We're just using the relationship between degrees and radians. Okay, so now we're going to talk about reference angle. So a reference angle is the smallest possible angle made with the terminal side axis. And it's really, really important that we remember that the reference angle is related to the x-axis, not the y-axis, but the x-axis. Okay, and that they're always positive. No matter which direction you're going, they're always going to be positive, these reference angles. Okay, so let's look at this. This angle is 240 degrees. From here to here, we know is 180 degrees. So our reference angle, which makes an angle with the terminal side and this x-axis, this angle is going to be what was left over after you subtracted 180 degrees. So we take 240 and we subtract 180 and we are going to get 60 degrees. And so that is my reference angle, 60 degrees. So this guy right here would be 60. Okay, let's look at another one. Okay, so now this angle that's represented is a negative angle, right? So this is a negative angle. Well, we have almost gone all the way around. We just have this much left to go. So our reference angle, which is made by the terminal side and the closest x-axis, which is right here, this reference angle is going to be what's left from 360, because 360 is when we go all the way around. If we went all the way around, that would be 360, okay? So what we're going to do now is we're just going to subtract off our 300, and we will see 60 degrees. So again, this reference angle is 60 degrees. Now, what's interesting is if you see, the first example 5, had a reference angle in the third quadrant. Example 6 has a reference angle of the same value in the first quadrant. So you see, it just depends on where you are and how you can use it. Okay, let's look at this one, and I think graphically it's going to help you. If you think about, this is 0, right? So we're going to have this angle starts here and goes 7/6 pi. Well, that means that we are going to break this pi into 6 pieces. So if I go this far, for this far, I'm going to have 6 pi over 6. So I'm going to have 6/6. But this says that I have 7 pi over 6, so that means I'm not done. I'm going to keep going, and I'm going to go 1 more 6th. Okay, so that's why I went 6, 7, 6. Okay, so but our reference angle is going to be related to the x-axis and the terminal side. Well, here's your terminal side, and the closest x-axis is here, so this is my reference angle. Well, you can see that out of my 7 pi over 6, from here to here is 6 pi over 6, so we only have 1 pi over 6 left. So this would be 7 pi over 6 minus pi, which is 6 pi over 6, because we need a common denominator. And then we get 1 pi over 6. So our reference angle right here is pi over 6. And again, positive because it doesn't matter for reference angles. Okay, let's look at 3 pi over 4. Now we're going to think about the same thing. We're going to think about this pi, we're broken into 4 pieces. So 1, 2, 3, 4. But we are only using 3 of those. So we start here and we're going to go 1, 2, 3. So we're going to end here. So there's our terminal side for 3 pi over 4. Well, that's great, except for that's not our reference angle, because we're going to take our terminal side and go to the closest x-axis, and this is our reference angle. So you can see that our original angle, 3 pi over 4, and we add that to our reference angle, and we will get pi. Well, if I want to find out what was left, I take pi and I subtract 3 pi over 4. But I need a common denominator. So this is the same as 4 pi over 4. Pi is the same as 4 pi over 4. So you can see the 4 minus 3 is going to give us 1 pi over 4. You can see that we only had 1 pi left over 4 to get to our x-axis. So this will be our reference angle. Okay, guys, I hope this helped. Take care.